Hi folks, and welcome back to Math with Captain Rod. I'm making this video here to be kind of an introductory video here of how to find the range of a function. So the answer to that typically is this: you graph it. And you know, depending on the class and how skilled you are and a lot of different factors here, that could take the form of a couple different ways. One, we could be graphing by plotting points or just by knowledge of the graphs, or there's lots of different ways to graph it. Also, maybe a graphing calculator aid can be used. The point of this video is not about how to generate the graphs. It's going to be about how to look at the graphs and determine what the range is. So I'm going to assume when I do this video that anybody watching it can generate the graphs needed for whatever function we're looking at. So we're going to take a look at this function first. I chose nice easy ones because I don't have a graphing aid handy. I don't feel like doing a lot of work for graphing complex functions. I'm just going to do some quick work here. This is a parabolic function and it opens down. While I'm at it, I'm going to chat about the domain of this, and hopefully you've seen my videos about domain. Always start by assuming all real numbers unless you find a problem. As we look at this, there's no division by zeros and there's no radicals. So there are no problems with this. You can put any value of x in you want, you're going to get a number out. So the domain of this function is all real numbers. All right, range. This is a parabola, it opens down. I know it goes through the point 0, 4. Let's see, if I put a 0 here, solve for x, I get plus or minus 2. That's going to be enough for just a quick sketch. And again, I'm just doing a quick sketch here. Looks something like this. For those of you who love graphing calculators, you can put this thing in and maybe set your windows from, I don't know, -10 to +10, both directions. You'll get a picture that looks something like this. So the range has to do with the output values, the y values. And if we look at some y values here, like that y value is 4. And then there's a spot here that's going to give me a y value of about 2. That would be about like this, or I'm sorry, I guess that's more like 2.5 or so. And y equals 1 is there, y equals 0 is here. If I go over here, y equals -1 is here, negative maybe 4, negative whatever. All right. When you look up here, though, there's no part of this graph where, say, y is equal to 5 or 6 or 7. The largest that y can be is 4. All values of y are less than 4. Like y could be 3, 2, 1, -1, -10, -100, -1 trillion. No matter what value you choose, like -1 trillion, it's there somewhere, way down here. So the range of this function is all values of y less than or equal to this one, 4. So domain was all real numbers, range y less than or equal to 4. Let's take a look at this function here. I chose an exponential to talk about next. If we were to sketch this, let's see, I know it goes through the point 0, 1, and 1, 3, and 2, 9, and this graph looks something like this. That's just a rough sketch, but if you run this through your calculator, or if we plot a bunch more points, it's going to look something like this. Again, the point of this video is how to interpret the graphs as far as domains and ranges, not how to generate the graphs. I'm going to assume that whoever's watching this here has some idea of how to generate these graphs. And again, we'll talk about domain as well while we're looking at it. Start by assumption of all real numbers, and then you eliminate things by looking for division by zeros or even roots of negative numbers. So there's no divisions in this problem and there's no radicals. So the domain of this function, again, is all real numbers. You can put any value of x in you want. You're going to get a value for y out, no problem. Now we're going to take a look at the outputs. If I look at this one, that one's like y equals 1. If I move over 1, y is 3. It's not to scale. Next one's y 9. And no matter what value I choose, I could choose, again, 1 trillion. That's here somewhere. Somewhere there's an x value. If I go all the way up, I'm gonna get a trillion out of that. No matter how big a number you choose, it's there somewhere. I can put in any value of y I want numerically, big numbers, positive, and I'm gonna get a value of x out. Look at what's happening on the left. You know, this is some value less than 1, a lot less than 1, quite a bit less, getting smaller and smaller and smaller. So y, the y values are heading towards 0. And you'll notice there are no values of y down here anywhere. So our range of this function, right, y is greater than, for now I'll just put or equal to 0. You'll notice that these y values are all positive. That's the mathematical way of saying that. And no matter how high I get on this curve, no matter how big a number, it's there somewhere. Now let me talk about the equality here. This thing goes forever to the left. But no matter how large a value you put in here, -1,000,000, -1,000,000,000,000, negative quadrillion, no matter what, you still do not get identically 0 out of this thing. So there's actually no equality on that. So I'm going to go ahead and erase that, because there's no value of x that's going to give you identically 0 out for y. So the range of this function is all numbers strictly greater than 0. So the point of this video is to get an idea of how to find the range of an algebraic function. My quick answer is graph it, and then you look at the possible y values coming out of that function. I hope that this helps demonstrate these concepts. Have a great day.